Okay, welcome everybody. So we were talking about revision control and Git last week, and we're almost done with what we need to know about Git. Git is a very large system, very powerful revision control system. Architected and the original author of it is Linus Torvalds, the same person who created Linux. So pretty impressive record of incredibly influential open source development because Git is the world's most popular revision control system today. I saw an estimate on the web that 70% of revision control users are using Git. So if you're going to use one system, it's the right one because it's used widely, not just because other people use it, but because it is powerful. Now that power does come with some complexity. So I'm going to finish off this lecture telling you a bit more about Git, go through the quick start guide and milestone 0, which are going to teach you a bit more. And in the tutorial next week, Abid and I are going to live demo doing some Git commands and interpreting the output that comes out, where two of us are actually collaborating on a repository. So come to the tutorial next week. That's not the only thing we'll do, but that'll be part of the tutorial next week. And obviously we'll record it too. But we're not teaching you everything about Git. There are many ways to use it, so you can learn lots more on the web. We're teaching you a flow which is quite productive. It's called the centralized development flow, and it is probably a bit easier to learn than some other flows that you can do with Git. All right, so we talked about the need for revision control and basically the problems that revision control solves, and then some Git commands about how do we actually do that. So far, I've actually been simplifying Git a little bit. So this slide shows you the kind of complete architecture of Git, which I've been simplifying to this point. So we're gradually kind of peeling layers back and showing you more of the complexity that is in Git. Okay, so Git actually has, you've already seen that you have these working copies, which are the files that are in your own directory on your own machine that you're editing, you're saving, you're compiling, you're testing, and you have a repository where all the versions of your program that you've ever committed and pushed live. And not only you, but also your team members can access that repository so you can share changes. That is standard across all version control systems. Git adds something that is more unique to Git, which is it adds actually another layer of repository. And you don't need to worry about this too much, except you need to understand it enough that you can comprehend some of the Git output and why you run the commands you do. So in a little more detail, let's take two people. Alice and Bob are two-person team in this course, and they're working together to complete their project. Okay, so Alice has her, well, let's say they all start the day, both of them start the day with the same code. Okay, and the code is two green files and a purple file. So that's what they had last night. It's in Bob's working copy. So that's the code that's on his machine. And it's the code that's in the centralized repository. Alice comes in and makes some changes. So she makes a change where she makes this red file. Okay, she makes some edits. We'll color that file red. So it's different. Now Alice wants to save those changes not just in her working copy, but in the repo, and she wants to share them with Bob because she's a good developer. She knows I should share these changes as soon as I've tested and they work. So she wants to do that. So what does she do? Okay, so she does a commit. You've already seen that command. What that commit does in a little more detail is it actually moves that change, or not moves, but commits that change to what's called her local repository. So her local repository has all of the commits that she has done and basically Bob has done for this project. So it's the repository that I showed you before, but it's actually on her local computer. Okay, so the commit puts her changes into there, and she puts a message on it and so on. And if she does git log, she'll now see that she's committed these changes. Bob still can't see these changes. Okay, this is why she does a push. She does a push to actually take what is in her local repository, could be one new commit, could be many new commits that she's done, and push them to the remote repository. The remote repository for this course, once you move on to the next milestone, is set up for you by the ECU 297 init command, and it lives on the UG machines. And it lives actually in a specific directory. So if your group number is 2, it would live in /group/cd002. And everyone on your team will have will set the permissions so that basically you're all connect. You can all be connected to that repository, but no other team can. So this push has moved her code off of, well, not moved, but copied all of her commits off of her local computer and pushed them onto this machine that is what's called the remote repository. It's kind of the central storage that Bob and Alice are going to share, and it lives on the UG machines in this particular directory. Now, you don't need to really worry about exactly where it lives. What's important, though, is that it doesn't live on your own machine, and that's why your teammates can actually see it. You're going to see some Git output. We'll talk about something called Origin. Origin is the remote repo. Okay, so that's like, it's like a nickname for this remote repository. If you see it talking about Origin, that's what it's talking about. Okay, now Bob wants to, Alice says, Bob, get my changes. I want you to see what you think of them, give me some feedback, and then build on top of them. Okay, so what Bob needs to do, well, first, let's say Bob does a Git status. I see this happen all the time in the labs. Bob does a Git status and says, I don't even see your commit, right? I don't see it listed in Git. I don't see it listed in Git log. I don't see, when I do Git status, it doesn't say that there's anything for me to do. It says my files are all up to date with my repository, so I don't think I have anything to do. Git status and all of these commands, except basically push and pull, are just talking to the local repo. So when Bob does things like Git status, Git log, he is talking to his local repo. He's not actually seeing what Alice has done in the repo. So that's something to bear in mind, because otherwise you might get confused. So what Bob needs to do is he needs to do a pull. And there are two versions of pull. Basically, we're recommending you use the version with the -R option. So he does a pull -R, which if you're reading the Git documentation, that -R stands for rebase. Don't worry too much about that. It basically brings the changes down from the remote repository in a way that makes your version history, your git log command, easier to understand. If you forgot the -R, nothing horrible happens. It's just pull -R will give you an easier to understand git log. Okay, so when he does that pull -R, what happens is his local repository sees these changes, and at the very same time, his working copy is updated. So we get both things up to date. At this point, he sees all of Alice's changes. He can work with those changes, and he can, commit on top of them his additional changes and push them back to the repository. You want to do these push and pull commands pretty often so that you don't have a bunch of changes that Alice or on Alice's machine in her local repository or her working copy that Bob's not aware of and hasn't seen. So you want to do this pretty frequently. If Bob now does at this point, Bob does a git log, he will see Alice's commits because they're in his local repository. Okay. And I see there's some discussion in the chat. I think I'll read that after. So basically, it looks like it's more than I can handle right now. Okay, so let's talk. Yeah, git log only shows the info on the local repo. It talks to your local repository. Basically, Git, almost everything is talking to your local repository. When you do a git push, a git pull, those are how you communicate between your local repository and the remote repository. But a good rule of thumb is in Git, except for those commands, everything is just talking to your local repository. And if you don't remember that, you could occasionally get confused because your teammate might go like, what's going on? I actually committed, I even pushed it, and you don't see it. You got to do the pull. You won't even see that the changes exist till you do the pull. Okay? And yes, that means team members have a different output from git log if they haven't done a pull. If they all do a pull and therefore they all are in sync with the local, with the remote repository, then they'll all see the same output. But if they don't do that, some of them are making commits and not pushing them, some are not bothering to pull, then they can do git logs and get different answers because they haven't shared their changes all the way through. Okay? So yeah, the order when you come in the morning is you basically, if you don't have anything going on in your code, so you haven't made any changes, do a pull. Okay, you do a pull to see if your teammates done anything. And if they have, it brings it into your working copy and your local repo. You immediately do a build and test if the pull did anything, because you basically go, okay, my teammates did something. I just want to make 100% sure that things aren't broken. Because if they are later on, I'm going to have trouble figuring out if it's my changes or theirs. So do a pull when you don't have, you come in the morning and you have no local changes, basically. Do commits. You could do one commit, you could do several, but don't commit for too long before you do a push. Try to commit your changes, and then when you've got a reasonable amount, you've gotten to a good spot, you've built, you've tested, you're not going to break the build, meaning you're not going to just break the code so nobody else can compile it, or you broke tests that used to work. You push it so it goes to the remote repo, and then you can tell your teammates you should pull this. So in case they weren't thinking of pulling it for a while. Does that make sense? Pull, I see a question, doesn't Git automatically tell you to pull if there were changes? If you try to push and there have been changes pushed by somebody else since your last pull, it will tell you you can't push. All right, that's where you get that somewhat cryptic can't do fast forward merge message. In that case, it tells you, okay, there have been changes, you got to do a pull. Not going to let you do a push until you do that. If you just happily code though and commit without doing a pull, and you don't try doing any pushes, you could just keep going forever, not knowing that your teammates are madly changing the code. You're just working on your own working copy and committing to your local repo, and are not actually seeing that your teammates are making significant changes, some of which might conflict with what you're doing. So to avoid that, you want to push often, you want to pull often. Okay. Let's say I pulled and got an error after running it. How can I cancel the pull? You can't really cancel the pull. You could basically check out. You can use the techniques that we go over in milestone 0 to basically check out an older revision if you pull down something and it's not working. Okay. I see lots of other questions. Is the index in the local repo? The index isn't quite in the repo. It's basically what are you going to put in the repo on your next commit. So it's for talking to the local repo, but it's not even, the index is basically would be here. Index is a list of changes that you've told Git about with commands like git add. And the next time you do a commit, those changes will go into your local repository. So the index is, sometimes called the staging area. These are the changes that I've made in my working copy, which I want to put in my local repo with my next commit. All right. Let's see. Let's say I've written some code and I do pull-r. Will my code get lost? No. If your code has not been committed, so it's just in your working copy, but it's not in your local repo, Git will refuse to do the pull. It'll basically say you have uncommitted local changes, or it'll say uncommitted or unstaged. I forget exact message it gives you, but it'll basically say you've got changes. If you do a pull, you might lose them. You don't want to do that. So it won't let you do it. Once you commit them into your local repo, when you do the pull, basically Git integrates your changes with whatever was in the remote repository. So that's where it does the things we talked about last week. Let's see if I can flip back fast enough here. These things, like if you have you've edited part of a file, your teammates have edited another part of the file, it actually figures out what the net impact of all the changes are, and it puts that in your working directory. So it doesn't just overwrite files, it basically integrates the changes from your teammates into your working directory and into your repo. The one case where it can't do that automatically is you and your teammates have both edited the same lines, and in that case, Git will tell you there are conflicts, and because you've both edited the same lines, and you're going to have some manual work to do. You're going to have to go into those files, see those conflict markers, which I showed you last week. Remember, these are the conflict markers where it's basically telling you you've got changes that are conflicting, and you're going to have to resolve those. So Git's going to say, you got to do this before you go any further. But that's a long way of saying no, you won't lose changes. You'll be told to commit if you have changes you haven't committed. After that, you can do a pull. The pull will merge the changes automatically as long as they're not conflicting. If they do conflict, you have some work to do. That's another reason you want to do push and pull pretty often, because you don't want to create long lists of changes by both Alice and Bob, and a high potential for conflicts that have to be manually resolved with like editing files. It's a real pain. Okay. So let's move on. And Learning Git takes a little while, so that's why you're doing milestone 0. You should really play with the commands. Don't try to just race through the milestone, and read the Git quick start in the milestone 0 document, and come to the tutorial next week, and you'll see more of a demo on Abbott and I running some of these commands. Okay, so let me talk about another couple concepts in Git. Branching. It's a more advanced feature. It's not required for this course, but it might be useful. And you're going to see lots of discussion of it on the web. So let me tell you what it is. So, well, first let's start with why it exists. So let's say Tony Stark is finishing off milestone 1. So it's working. He's just fixing the last few bugs. Bruce Wayne's got nothing to do. He wants to start work on milestone 2. But we don't want him breaking anything now because Tony hasn't finished milestone 1. He's fine-tuning. Then he's going to submit milestone 1. So what we want is for both of them to work simultaneously without kind of conflicting with each other. We don't want Bruce making risky changes that are going to show up in our milestone 1. We'd also rather not tell him to stop work. So branching is the solution to this. Okay, so what does branching mean? So far I've been showing you what's called a centralized development flow. So you'll see that terminology used with both Git and other revision control systems. It means there is one kind of linear chain of commits. So I've numbered them all. Revision 99 was by Tony. Revision 100 here is by Bruce Wayne. Revision 101 is by Tony again, and so on. And the default branch, the one that you're working on in this course, is called master. Okay? So Bruce Wayne wants to keep working on master and start going on milestone 2. But we don't want, Tony's got some fix-ups to do for milestone 1, and he just does not want to see any of these changes that Bruce is making because they're too risky to do at the last minute before milestone 1. So what he does is he does git checkout, which remember gets a copy of the code out of the repository and puts that code into his working copy. But he gives it an extra flag, this -b flag, and that -b means branch. Okay, so he's creating a branch and he has to give it a name. So he's creating a branch and he gives it the name, could be anything. He calls it M1 branch for milestone 1. So this checkout has created, again, a new branch. Bruce just keeps working away on the master. So he's committing, he keeps working. But after Tony does this checkout, his commits now, by default, go onto this branch. So he makes a revision called revision 103, and Bruce makes other revisions, and they're going on basically 2 parallel chains of development. These commits are not applying on top of each other. They're like separate, divergent paths of evolution. So the code started at the same point here. It branched into 2 different evolutionary paths. Tony is making some changes, and he does not on this branch see any of Bruce's changes. And similarly, Bruce is making changes, and he does not see any of Tony's changes. Okay, and this is a useful thing because again, it's letting them work more independently. Now there is a cost to it. Now let's say they do this and they make all their commits that I just showed you. Turns out that Tony found a key bug in some of the code that he's writing for milestone 1, but that bug should really be fixed permanently. It's going to actually mess up their milestone 2 as well. So what he can do is there's a command called git merge that allows him with the proper parameters to take the code that is in this commit, this revision 106, and apply those same changes to the master. So make a new commit up here to the master, okay? And that would be, say, revision 107. And in many cases, it can do this completely automatically, which is nice. However, the longer these branches go on, so if they lasted 1 day and there aren't very many commits, the odds of this git merge being able to just take the code to fix this bug in revision 106 and apply it to revision 107, well, apply it to the master automatically without asking questions, without having conflicts, is quite high. If they work independently for 3 weeks and make a whole bunch of commits, then it's quite likely that if Tony tries to do this merge, he's going to find that Bruce also changed some of those lines, and there's going to be conflicts, and he's going to have a bunch of manual work to do to integrate that change. So that's the cost of branching. You often have to fix things in 2 places. And if the branches have diverged a lot, then that will usually involve some manual work, because git merge is going to say there are some conflicts where you've both made edits. I can't quite figure out what to do. You got to tell me. So for large software systems, use branching to do releases. So I just talked, basically Bruce and Tony are using this branching strategy so that Tony can essentially release milestone one, like get it in perfect shape while Bruce keeps working. And large companies do this on a bigger scale. So you want to release a new version of your code. You have to make sure you go into a bug fix mode where people are not experimenting or trying things that are major new features when you're trying to stabilize it to release the next version of Windows, for example. While you're doing that, that may take months. You don't want to tell all your developers, well, no one can do anything that is a new feature. So the developers who don't have bugs to fix in the version that's about to go out, say Windows 11, can keep trying new things that will go into Windows 12, and that would be on the master branch. So how early should you branch? So there's different opinions about this. If you do it sooner, you have longer for stabilization. So let's say it's Windows. Windows is probably going to branch pretty early because there's a lot of testing to do, very high risk of bugs, a lot of things to get right. But the longer you have this release branch and the master branch both alive, both getting changes, the more time you have where you have to fix bugs in two places. In Altera, we branched about 3 months before the release because it's not as hard to test, I would say, as something like Windows, but it's a big program. And the cost of bugs was quite high. So you can imagine your 241 bug lab, when Cortis has a bug, some of those bugs could actually make your hardware not work, which is incredibly annoying. Like those are the worst bugs. So you're trying to design hardware, you get your Verilog right, but the CAD tool is broken, so your hardware doesn't work. That's really, really hard to sort out. So there's a high cost of bugs, so we spent 3 months testing. It did cause extra work though. So for 3 months, developers, every bug they found on that branch, they had to go fix it on the master as well. So there's a question I see of, does it matter which branch is master and release since we'll be merged in the end anyway? Yeah, it does matter because the master by kind of convention lives on. So if I look at this one, this M1 branch, you would just stop developing on after a while. If you think of Windows 10, at some point, there'll be very few bug fixes, maybe none. But the master will one day become Windows 11. They'll be branched off. And then someday there'll be another branch for Windows 12 and another branch for Windows 13 and so on. So the master, as long as the code quality is high and people can understand it, can live forever. It's like the living evolutionary path. The branches are going to get stabilized and improved for a while, and then people will stop developing them. Okay, so my preference is to branch late. It leaves less time for stabilization, but less duplicate work. But yeah, you can't push it too far. So at Altera, I was considered a little more of a cowboy, but it never went too far where I broke Cortis. But I didn't like doing branching too early because it reduced the productivity of developers. Okay. You're also going to see as you search about things on the web about Git, again, we're following what's called a centralized development flow. So if these dots are all commits, you're working in a way where you wind up with pretty linear commits, right? We're not explicitly branching. There are other development flows where basically people branch all the time. And every little feature is a branch, and then they do a merge to bring it back in. Also can be a productive flow. Both of these flows are widely used in industry. The feature branch flow is a little harder to get right when you start, right? It's easier to get confused. And because you're not used to working on a team, what often people do if they try to use a flow like that is they just don't talk to each other much and they leave it to the end. So we're using, again, what is kind of a single line of development flow, which is a productive one, but not the only one. Okay. Yeah, there's a question, can you branch from a branch? And yeah, the answer is you can. I see there's a question, can revision 106 be merged with previous revisions of the master branch? It's probably possible. Git will let you do almost anything, but it doesn't make that much sense. What you're trying to do with this revision is you're trying to get this Git merge, you're trying to get a new commit that's at what's called the tip of the branch. So it's like the last thing. Because if you can get your changes on the tip, it's like the last thing, then you can say everything is here. And if you tried to do a merge into some previous commit, it doesn't really make a whole lot of sense because you still have all these changes after that commit that you somehow need to get in. Okay, so people normally don't do that. Um, Although, as I say, Git has many commands and many options, so I can't say that you can't do it, and I can't, but it's something that normally people wouldn't want to do. So, and if you don't like 107 and you want to continue from 105, normally you would do something like revert. You would say, I want to get rid of this. Okay, so let's use that revert command and get rid of that commit. So you still have to wind up with something useful on the tip. The tip of these branches matters. That's the last revision. It's where what's called the head pointer that you're going to see Git talk to you is. Where am I pointing? Where will my changes go? And that's actually one of the changes I made in the slides. I went back and noted where the head pointer is because that might be helpful to you. All right. So let's see, a few references, then I want to hand it over to Dr. Tallman. So we've got the ECE 297 Git Quick Start Guide. Definitely read this, complete the walkthrough. I think you're going to really regret it if you do not read this. First part is command line, which is what most people use. If you prefer a GUI, the second part is essentially the same thing, but how do you do it through the NetBeans GUI? As I said, Git's big. This is a walkthrough of the parts we really consider essential for this course. There are many, many online guides and posts. I like this Git tutorial at Atlassian. It's big, but it's pretty readable if you want more. You want to go even further, there's a book called Pro Git. It's several hundred pages long, so this is big. It's way more than you need for ECE 297. But if you're like fascinated, you want to learn lots, you can go read it. It's available online, so you don't have to buy it. You just go click on it. And there's a reference for all the Git commands that I put in here. Now, this reference is probably a bit hard to understand if you don't, well, it is hard to understand if you don't have the basics of these other things. All right, it'll tell you here's the syntax or the way you can call this this Git subcommand like checkout, and it's got many options. But you don't want to start with that Git command reference because if you haven't read these more basic guides to figure out what am I trying to do, this command reference will probably seem overwhelming. But when you want to find, hey, what are all the options? What's the syntax? It's a good, quick place to go. Okay, that is it for me. If there are any questions, ask them quickly now or type them in the chat, and I'll hand it over to Dr. Tallman.
Great, thank you, Vaughn. Do you see my slides up there, Vaughn?
Yeah, I see them.
Okay, excellent. So I'll talk through written document today, and I'm going to try to move pretty quickly. I've got a video clip I want to show and have you respond to it, so I might move a little quickly to get there. Let me just get the chat up here so I can watch that. And let's see there. Good. So the objectives today are I don't know how far we'll get. We'll continue with it tomorrow, but that we practice applying made to stick principles to an oral presentation. In this case, a presentation by Steve Jobs, his launch of the iPhone, and that we
everything you need to know about Apple products is at Apple's website.
Sorry. Siri just came on my iPad. Excuse me, Siri. Yes, that we practice using the WD0 instructions and the grading rubric so that we can better understand the assignment instructions. And just a heads up to you, if you want to get some help with WD0, we have some dedicated sessions that are specifically reserved for you, for ECE 297 students on January 27, 28, and 29. So the Wednesday, Thursday, Friday before the assignment comes in. And there's limited number. So if you are interested in getting a 30-minute kind of one-on-one session with a tutor from the engineering communication program, book here and book soon, okay? Vaughn has already talked to you about the deliverable sequence. So just very quickly on the communication side, We have WDO, WD1, written document 1, then 2 oral presentations, one after the reading week, March 22 through 26 in your tutorial slot. And then the final presentation we have tentatively scheduled on April 20, just when the final exam period begins. And then beginning next week, you're going to start to meet with your CIs on a weekly basis, most weeks of the term. And you can see the values for these different components. WDO is the one individual assignment that's not directly connected to the design project. The other assignments are directly connected to the design project and are team-based. So the made to stick principles, maybe you could just in the chat quickly identify the 6 different principles. Anyone? Yes. And good, I like, yes, success is the acronym that brings them all together, right? Simple, unexpected, concrete, credible, emotional, and stories. Success without the final S. So a good way to remember them. And so I want to go just quickly now to, I've just included an excerpt from the WDO assignment instructions. And many of you have already started to work on this. I know I've seen a number of questions in Piazza. And the essential requirement is that it asks you to use 3 communication principles that are described in Made to Stick to assess Elon Musk's launch of the Tesla Cybertruck on November 21st, 2019. And the URL for that is included in the assignment instruction. So go to that on Quarkus. And we want you to only look at the first 11 minutes, 30 seconds for this assignment. You can certainly look through the rest of the presentation. It's entertaining. And the key components are that you summarize 2 of the principles from Made to Stick. You explain how Musk's use of these principles makes the presentation effective and memorable. And then you make a case for one area in which Musk could improve, drawing here on a 3rd principle from Made to Stick. And I'd say that the key goal in this is that you employ the Made to Stick principles to make your analysis memorable, okay? In terms of references, we want you to use timestamps to refer to the video. So if you're referring to something that Musk does that demonstrates one of the principles, give us the timestamp for it. So we can go and look from 4 minutes, 40 seconds through 5 minutes and 5 seconds. And please use the IEEE citation guidelines to refer to Made to Stick. And there's been a number of questions already in Piazza about citing an IEEE. And you'll find different information in different places about how to do it, how to refer correctly to ebooks. And my general advice is, take guidelines that make sense to you. We've posted a set of guidelines in Quarkus, but you may find other information and other sites about IEEE citation that you think will suit your purposes. And we'd say whatever it is that you choose, be consistent. Just use it consistently. And if you're in doubt, post on Piazza or ask your CI. And yeah, can the slides be posted on Quarkus? I'm going to post these directly after the lecture, so you'll have those. And I would say that the introductory statement that you make, short introductory paragraph, short concluding takeaway, these are excellent opportunities to employ Made to Stick principles. So going back to 2007, maybe some of you have watched this. It's a kind of I guess a bit of a legendary presentation. And what I want to do today is I want us to take a look at the first 4 minutes and 40 seconds roughly. I'll stop at that point. Excuse me. And while you watch the video, I want you to note 2 principles from Made to Stick that Jobs uses, whether it be simple, unexpected, credible, concrete, stories, emotion, whatever it is, note 2 of them. And when the video is complete, we'll go into breakout rooms for about 5 minutes. And in the breakout rooms, each of you will explain to your group how Jobs uses these 2 principles that you've noted, either effectively or ineffectively. And so I will get to the video right now. And Vaughn, if you could just give a thumbs up if the audio is working on this.
This is a day I've been looking forward to for 2.5 years. Every once in a while, a revolutionary product comes along that changes everything. And Apple has been, well, first of all, one's very fortunate if you get to work on just one of these in your career. Apple's been very fortunate. It's been able to introduce a few of these into the world. In 1984, we introduced the Macintosh. It didn't just change Apple, it changed the whole computer industry. In 2001, we introduced the first iPod. And it didn't just change the way we all listen to music. It changed the entire music industry. Well, today, we're introducing 3 revolutionary products of this class. The first one is a widescreen iPod with touch controls. The second is a revolutionary mobile phone. And the third is a breakthrough internet communications device. So, 3 things: a widescreen iPod with touch controls, a revolutionary mobile phone, and a breakthrough internet communications device. An iPod, a phone, and an internet communicator. An iPod, a phone. Are you getting it? These are not 3 separate devices. This is one device. And we are calling it iPhone. Today, Apple is going to reinvent the phone. And here it is. No. Actually, here it is, but we're going to leave it there for now. So, before we get into it, let me talk about a category of things. The most advanced phones are called smartphones, so they say. And they typically combine a phone plus some email capability, plus they say it's the internet, sort of the baby internet, into one device, and they all have these plastic little keyboards on them. And the problem is that they're not so smart, and they're not so easy to use. So if you kind of make a Business School 101 graph of the smart axis and the easy to use axis. Phones, regular cell phones are kind of right there. They're not so smart, and they're not so easy to use. But smartphones are definitely a little smarter, but they actually are harder to use. They're really complicated. Just for the basic stuff, people have a hard time figuring out how to use them. Well, we don't want to do either one of these things. What we want to do is make a leapfrog product that is way smarter than any mobile device has ever been and super easy to use. This is what iPhone is. Okay? So.
Okay, excellent. So I am going to send you now to breakout rooms quickly. We'll get there for 4 or 5 minutes. And in those rooms, explain to your teammates, your group, how Jobs uses the 2 principles that you've been kind of noting, either effectively or ineffectively. And let me just find the breakout rooms up here. What I'll do is I'll stop my share here, just 1 second. Interesting, I'm not seeing breakout rooms here as an option. Now maybe that's because I should as co-host. Do you see the breakout rooms there, Vaughn, on yours?
Yeah, I can start them, Ken. I think it might be because I started the meeting. How many breakout
Okay.
rooms would you like?
I was thinking of maybe about 65.
Okay, let me try.
Or actually make it about
There's
60.
a limit on
We've
how
got
many
fewer.
you can do. I'm not sure I can do that many. I think 50 is the max. So I guess that
Okay.
decides it.
Sure.
Okay, so I'm going to create these. And we're going to do a countdown of 15 seconds when we go to close them. Okay, so I'm going to open the rooms. Is that okay, Ken?
Excellent, thank you.
Ken, tell me when you'd like me to close them, okay?
Can someone send me to a room, please? I don't know where my pop-up went.
Sorry. Let me go do that. I'm just trying to figure out how to put you in a room. Let's see. Okay, let's see. I'm looking for how to assign you to a room. So what exactly happened?
The window popped up, and then I think I clicked like outside of Zoom, and then it like disappeared.
Sorry about that. Yeah, I'm not seeing. Maybe it's still open somewhere. I'm not sure. But yeah, I'm looking through. I don't see where to put you. So what do you think? I guess I can do a breakout room with you if nobody else is coming. So what What do you think? I think Dr. Tallman asked, what principles are they using?
There was one where he was referencing things that people are familiar with, such as leapfrog. So that's one of the things he mentioned. And then
What
also
principle do you
uses
think that would be?
I don't have the list of the principles, but let me just like I don't know like the exact name of like the 6
It's
principles.
maybe concrete. You know, when you make analogies
Yeah.
to things that people really understand, that they can kind of touch, it kind of makes it not abstract. Instead of saying, I have a great new device that does all sorts of stuff, if you say, it's like this, but better, it's kind of more concrete, right? So it's,
Yeah.
I remember, well, I like the book talking about the movie Speed, that it was like Die Hard on a bus. It's kind of both simple and it's very concrete. If you've seen the movie Die Hard, you kind of immediately know, okay, what are they talking about? So
Right.
I
And he
should
also
probably,
introduced it as like 3 things that people know, such as like iPod, cell phone, and then 12 the third one was, but like, and he just ties them all together. But those are all really concrete because those are 3 separate things rather than saying like, as you
yeah,
mentioned, like this device that does everything.
yeah, makes sense.
great. Thank you. A quick breakout. I'm hoping you're all back with us. We've just got a couple of minutes, and we could use the chat here. Certainly, I'm just interested to get a few of your comments here. If you could be kind of specific about which principle and what it was that Jobs did that demonstrated or showed the principle. So I hear from, I'm just looking at Sona that we've got lots of thoughts here. Concreteness, expected 3 products. Yeah, I guess we already knew that it was 3 products in one, but that was kind of maybe a little bit unexpected, I think is maybe what Peter was saying there. And simple that he repeated three times, right? He repeated what was what the 3 elements in the phone, right? That it's internet, it's iPod, and it's email, and doing it 3 times delivered the core message. And so that was effective. So the repetition, so does the repetition make it not simple? I think the repetition helps to deliver the key message, right? I think that's probably the effect. And I see Isidore here is saying that the chart is not really concrete, an abstract sense of easy to use and smart, and probably true, but certainly easy enough for us to understand in that quick presentation. So easy to process graphics. And I see Taha is mentioning concreteness. The parameters of the proposal were clearly defined as significant improvements to those that came before. That's right. And that sort of also then sets up a story, right? He's sort of telling the story of Apple. Here's where we've been, here's where we've come from, here's where we are. So it sets up that kind of beginning, middle, end structure that helps to make it memorable. And as Tassif says, besides, he's just a great presenter. And many feel that way, right? He's very easy to watch. He's engaging. And as Isidore says here, he took advantage of already being a credible authority. So he comes in with credibility. He comes in with the credibility of the past products. So he uses those past products to help to establish the credibility. And Vaughn is noting that maybe Elon Musk could learn from Jobs. Well, I don't want you to be biased in your your analysis of Musk's presentation, but clearly very different presenters. And go ahead, Vaughn. You're
Ken,
muted.
that's a quote of a student comment. I just like the
Oh,
student comment, as the student comment is. I'm not saying whether I agree or disagree, but it's very
okay.
concrete. You can visualize the two people.
Right. Okay. Very good. And so I see Peter Lotka, one of our CIs, saying that Musk's approach is sort of post-Jobsian style. So well, so we can discuss that at a later time. Um, And yeah, and that's a good point, Tatsif, that the iPod rotary phone is kind of unexpected. It grabs our attention, right? So I think we could probably see how he's using all of the principles in different ways, and for the most part, pretty effectively, I think, right? Now, others there's certainly things that we may see he could have perhaps improved upon. But what I'm going to do is tomorrow, when we come back on Thursday, I'm going to start in and we'll look at some kind of examples of how a student might have written the WDO assignment using the Steve Jobs presentation as the foundation, and we can critique the analyses. That are we'll look at those. So listen, so thanks everyone for being here, and we'll continue this tomorrow. And I'll stay here, and maybe Professor Betts will as well, if you've got any questions you want to ask right now. And otherwise, we will be seeing you tomorrow. Okay, I see that two participants have raised their hands. So maybe we'll take those questions. Go ahead.
Yeah, Professor, I had a question about like the graph that Steve Jobs presented. Would that count as credible maybe? Because I'm a bit confused because he didn't use any actual statistics, but the book also talks about like just showing things relatively, using things that people already know to sort of establish a baseline. Like numbers in and of themselves don't mean anything. And then I also feel like because of the fact that he showed that Apple had a history of innovation, we have a tendency to believe him already. So like, does that graph fall under credible, or is it?
Well, we could maybe see it from both sides. I think, to me, given the audience that he was presenting to, it's probably fits into exactly what an audience like that would be able to understand and relate to. It's simple enough, but it's presented as a kind of, I think he calls it like a business 101 graph. And so it kind of visualizes in very simple terms the point that he's trying to make. And I think creating that kind of simple visual in that particular circumstance probably does count as credible.
Thank you,
But maybe you'd argue differently. Good, excellent. So listen, I will be here. I'll stick around for questions. For those of you who want to get to dinner or get to wherever you're going for a walk or to sleep, whatever, we'll see you tomorrow.
Professor?
Yeah.
Oh, I just want to say that I think the reason why it was successful was exactly because of Steve's reputation, because I don't think the thing was recorded for like a general audience. I think I don't think the thing was recorded or the presentation was given for the people there. Really, the people there were kind of like, when you have comedians and you have clap signs, like for audience to clap. I think it was the same logic, because people who are watching like online or who watch the presentation later it adds to the effect. It adds to the selling point of those things. Yeah, I think it
Right.
was designed that way.
Right. Yeah. Okay. Good point. Yeah. I guess the audience there, clearly an enthusiastic audience, clearly an audience of kind of believers, but also an audience who are there because it's sort of their job to be there. They're part of the industry that's going to go out and market and sell these products. And so I think we see an audience that sees the opportunity for a benefit in this product. And yeah.
Thank you.
Yeah. So is it the common public? Well, I think that, that's a good question. I mean, who are they really targeting there? And I think that increasingly Jobs started to pitch his presentations for a larger audience because he saw that he had one. I think initially, as he started to roll out some of his earlier products, it was a smaller kind of industry group of people who would have interests in marketing, who would be there for his presentations. But soon his presentation started to gather kind of much larger interest. So he started to probably pitch it at a higher level for a more general public. Yeah. And let's see, do we have any other questions here? Okay, that's all I'm seeing right now. So very good. So I will see all of you tomorrow. And Vaughn, did you have any closing comments that you wanted to make?
Nope. No, thanks everybody.
Good. Okay.
I see there's a question. Do we have a tutorial today? Yeah, the tutorials are running this week. There are coding tutorials. So if your regular tutorial is later tonight, then it is running.
Great.
And I don't remember the schedule well enough to remember if there is one tonight or not. But if there's supposed to be one, there is one. So.
Okay, great. Okay. Good night.
Okay. Good night, everybody. Thanks.